All right, Science with Anne. We are going to explore density of liquids. I have a jar filled with cold water. I have some oil, and I have an empty glass that I am going to put some oil in. This experiment is called making fireworks, and it works because liquids have different densities. So some liquids won't mix as well with others, and oil does not mix with water. So now, I'm going to set my water aside. I'm going to put some, this is the oil, I'm going to put some food coloring drops in here. And the food coloring is water-based, so it will not mix with the oil. See how it's just leaving little drops there? Putting about 4 drops of each color. And yellow. There we go. Alright, so we just got a whole bunch of little drops there. See that? And I can even mix them up and break them up into little tiny pieces, but they still will not dissolve into the oil. Ooh, that's a pretty cool shot right there. Look at that. All right, so in theory, when I pour my oil on top of the water, it will not mix, and we should be able to have some fireworks. I'm going to put this paper behind here. I'm going to move my camera just a little bit so you can see a little better. And let's see what happens. See how the oil is bouncing back up to the top? And the suspense is killing me. Okay, now we just watch. There they go. Look at our fireworks. Woohoo! Oh, that actually is pretty cool. And there you have it, Science with Anne.
Hi boys and girls, we're going to make a rainbow river today. This is what you need. You need 7 glasses. Every other glass is about half full of water. So that means 4 of the glasses have water in them and 3 of them are empty. You're going to need 6 paper towels, and you're going to fold the paper towels in half and in half again. So I said we were going to make a rainbow. Rainbows are made of colors. So I also have some food coloring. This is the point where I probably should tell you that you should do this with your mom and dad so you don't make a mess. All right, we're going to start with red food coloring. And I'm going to put that in the first cup, and I'm going to put in 4 drops. Then I'm going to take blue food coloring, and I'm going to put it in the 3rd cup, the next one with water, 4 drops. Then I'm going to take the yellow food coloring, and I'm going to put it in the 5th cup, the 3rd cup with water, 4 drops. And then in the last cup, I'm going to do red again. And now we're going to make a river. So I'm going to take those paper towels that I folded up, and I'm going to put one end in here and the other end in the empty cup. And then the next one, like this. What do you think is going to happen? Can you predict what you think will happen? I don't know. All right, now we have to wait a little bit and let it work its magic. But if you look right up here, look in this blue cup, come up from top. And you can see it's starting to come up the paper towel. I wonder what will happen. We'll have to wait and see. I'll be back in a little bit. After about 10 hours, this is what my rainbow river looks like. So the water has come over the paper towel river and created secondary colors in the cups in between. So you can see red and the orange, and then the yellow and the green and the blue and the purple, and then of course back to the red again. I think if I let it sit long enough, the water will completely even out across all of the cups. That was a fun experiment. I hope you can try it at home.
Here's a simple science experiment for you using Skittles and a glass of water. I'm using warm water to see if it'll work better. I put the Skittles in a ring on a plate. I'm going to pour the water just in the middle of the plate. And we're going to watch and see what happens with the colors. You can see the colors start to move. They're moving towards the center, but they're not mixing. Kind of creating a swirling rainbow. There they met in the middle. Pretty neat, pretty simple.
Everyone, we are going to do an experiment today, and it's the tornado in a bottle experiment. For this experiment, you're going to need some food coloring, one of these connectors, or you can try and use masking tape to seal it up. I think these connectors work a little bit better. Here's the trick though, when you're doing the connectors, make sure that you take off this ring that's normally right here around the bottle, cut that off, otherwise it won't really screw on and be a nice tight fit. We discovered that because we've tried this already. So hopefully it goes better this time and the water doesn't squirt everywhere now that we've gotten rid of that. So first thing we're going to do is go ahead and fill up the water bottle. And you don't want it all the way full. I've already started filling it, but you know, most of the way. Okay, and so there we have our 2 water bottles. Okay, and James, thank you for miming along. Okay, and so we'll go ahead and what color did you guys say you wanted?
Red.
Red. Okay, so go ahead and add, do about 6 drops.
Wait. 1, 2, 3, 4, 5, 6.
Okay, so we've got 6 drops in there. Okay, and then we're going to go ahead and put our connector on. Do you want to screw that on to the top there, James? Okay, and flip the bottle over and go ahead and screw that piece on. Make sure it's really nice and tight. Yep. Okay, and then we will flip it over and then kind of start turning it in a circular motion. And we'll see our tornado. Pretty cool. Although I don't think it was very tight because it's still leaking outside the bottle. Yep, so be careful when you're doing that because it could leak.
Welcome to Science with Kim. Today we're making elephant toothpaste. You need hydrogen peroxide, should have got this out first. And dish soap. And food coloring for fun. Warm water and yeast.
Surface tension is the reason you can fit so much water on a penny. Water molecules attract each other, pulling together so the water doesn't spill. Let's see how many drops of water we can get on this penny.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.
Hello preschool, we're going to do a small science project based on our letter this week. Our letter this week is V, which starts words like volcano. So we're going to try to make our own volcano. If you do this at home, make sure you have a parent helping you, and it's always a good idea to wear safety glasses. We need to start with some baking soda. First, we have our volcano over here on the tray. We want to put it on a tray so it doesn't make a mess when it explodes. I just used a simple cup inside a plastic cup, but you can just use any kind of cup. It doesn't have to look like a volcano. You need to start with 6 tablespoons of baking soda. So we're going to measure our baking soda. You can help me count. 1, 2, 3, 4, 5, and 6. So the baking soda is going to go inside our volcano. So we want to tip it inside our volcano and save it in there for later. Once it's all in there, we'll go on to the next step. The next step, we need vinegar. So we need a 1/2 cup of vinegar. I'm going to pour it into here until it gets to 1/2 cup. We're also going to add a little bit of dish soap to make it foamy. So I have a 1/2 teaspoon right here. We want to use a whole teaspoon, but I couldn't find that. So we're going to just fill this up twice. There's 1. And 1 more. Okay. Then the next thing we're going to add is a little bit of food coloring. So inside a volcano, if you see over here, a volcano erupts and what comes out of it is red. It's called magma. So it goes from the bottom underneath the ground all the way up the volcano and out the top. So we want ours to look like magma. So we're going to add a little bit of red food coloring. You can use red food coloring or paint. Just 1 second, my food coloring doesn't want to open. So I'm just going to add a little bit of red food coloring in here. Put that in here for later. Then we're going to stir this container up. So stir up the soap, the red food coloring, and the vinegar. It's better if you have liquid food coloring, but I didn't have any at my house right now. So we're just gonna try it even though it's a little bumpy in there. Once you have that done, then you're going to get ready for the explosion here. We're going to pour our liquid into our volcano and see what happens. So over the top comes our magma. Explodes right on out there. Just like a real volcano.
Okay, this is called the God's heart exploding for us. Okay, so all I do is make paper hearts and fold them up. Now, here's the deal. Mrs. Sarvis, I get extra credit points because my heart explodes for you. That's why I did this science experiment. So that's extra points and I get extra pogs. Okay, ready? Just like the vibrant colors of a rainbow comes about and explodes over the sky for us, it's the same as God's love for us. And it teaches us patience. A lot of patience. Well, my bowl could have been a little bigger. Oh, just because I'm sure Kim is watching, I gotta make sure that it's proper. I would sing the Roy G. Biv song, but I don't really know it. So R, red, O, orange, Y, yellow. O, orange, R, red. Oh, I went backwards. R, red, O, orange, Y, yellow, G, green, B, blue, I, indigo. And I don't have a violet, so...
Kyle, go away from that side. My heart bursts for you, Mrs. Sarvis. Extra pogs, right? Do-do-do, do-do-do. There you go. Beautiful rainbow.
Hi, it's Mrs. Larson, and we are going to make for you today a non-Newtonian substance. Sounds fancy, but it's made with something rather simple. This is cornstarch. You might be able to find it in your cupboard. And water. Okay, cornstarch and water. And we mix it together. Ben's already got some here, but we're going to add some cornstarch. And then you just add some water until it looks kind of liquidy. And now mix that around with your hands. And you can you see how hard it is for him to mix that? That's because this substance, Isaac Newton a long time, he described some properties, things that liquids should be like. And then they saw this and they're like, that's not a liquid. But it's not, it's kind of a liquid. So it's called a non-Newtonian substance because it's not like what Newton said a liquid should be. So you can see, stop touching it, how shiny it is on top. And you can see it kind of moving around like that because it's liquid, right?
And then it's also...
So if you put your finger in there and let it sit, it'll sink right in, okay?
Quicksand.
But if you hit it...
like this, it makes a loud smack sound.
Because it's a solid. So it's a liquid, but it's a solid. Ben, make a ball. Can you make a ball?
Wait, I messed up.
So he's going to try and make a ball. And as long as he's squishing it, it kind of forms the ball. But as soon as he stops moving, it melts and drips like a liquid. See that? So
My hands are itchy.
you can certainly give this a try at home by just using cornstarch and water. You'll have a solid, but not really. And you'll have a liquid,
And then let me show
but not
you.
really.
Ben, take
Other
your...
things that are like it is quicksand. Quicksand acts a lot the same way. And that if you start moving, then it hardens up.
And gets sticky.
So try it at home. You'll be glad, Mom and Dad, to find out that once it dries, you can wipe it away and off of any surface. So have a good time with this one. Bye.
Goodbye.
Hi boys and girls, today we are going to make a magic rainbow. So before we begin, I will tell you what you will need. You will need Crayola markers, a Sharpie marker, a paper towel folded in half, a dish, and some water. Okay, so the first thing you're going to do is make sure that your paper towel is folded. Bounty probably works the best. Then you're going to draw with your Sharpie a rainbow. Try to draw as nice and dark as you can. So we have red, orange, yellow, red, orange, yellow, green, blue, and one more, purple. Okay, then you are going to open up the paper towel and you'll see some faint lines. And you'll color your rainbow. Color it nice and dark. Okay, I'm doing mine fast, but I'll show you the completed one, okay? So here's a completed one. I have a rainbow. And I have the top. Okay. So this is the fun part. Oh. Water in your dish. Put your rainbow in. Ready, set, go. Bam! And you have a magic rainbow. Isn't that cool? Bye.